Insertion sort. We're going to explain what it is, and then we're going to code it. Let's number some of these eggs and get started. Now this is going to act as an array. So over here, 5 is going to be at index 0 right now, and 7 is going to be at index 6. First thing we do for an insertion sort is you take the first element and say, okay, this is the first one going into the sorted part. So this 5 is considered in a sorted area, and then the rest are considered unsorted. And there will be a divider on the screen that you can see. Everything to the left is going to be sorted, everything to the right is still going to be unsorted. Okay, so now we are at number 2. Now what we do here is we take 2 out and we say, is 2 less than 5? Well, it is less than 5. So now what we do is we're going to take 5, we're going to increment the array index of its current position, so it's at 0, we're going to put it into 1. And now 2, because there's nowhere else for it to go, there's nothing else to compare it to, it goes right here where 5 was. And now we have our first iteration done. And we move the divider over. Now 2 and 5 are sorted, considered in the sorted area. And then we have 5 more elements to do this with. So we're going to move on to 4. We take 4 out of its position and we say, is 4 less than 5? It is. So we take 5. We increment its array index position. So now it's at array index of 2. And now we say 4, are you less than 2? It is not. So now we just put 4 right here. And now we're gonna move the divider over. And now 2, 4, and 5 are sorted. And 6, 1, 3, and 7 still need to be sorted, but they're considered in the unsorted part right now. We're gonna move on to 6. So we take 6 out. All right, now we ask 6, are you less than 5? In fact, you are not. So we don't actually perform anything and we keep 6 right here. Okay, we're gonna move the divider over and now we have 3 elements left in the unsorted area. Now we're gonna take 1 and we say again, 1, are you less than 6? It is. So we take 6, increment its position by 1. Now we say 1, are you less than 5? In fact, 1 is less than 5. So we take 5, move its position 1. Okay, now we say 1, are you less than 4? Yes, 1 is. So now we take 4, increment its position by 1. We move 1 down a position and we say 1, are you less than 2? It is. So now we increment 2's array index position. And now 1, it can't compare to anything else. So this must be the spot where it has to go. Now we move the divider over. Now, as a reminder, we're not going to be actually creating 2 different arrays besides the initial one we're bringing in code, right? That would be extra memory space that we don't need to use. This is considered an in-memory sort, so we don't need to do that. But this is just kind of like an abstraction so you can kind of visually see what's going on. We take 3 out of its position, say 3, are you less than 6? Why, yes, 3 is less than 6. So we take 6, increment its position in the array by 1. We move 3 down 1 and say 3, are you less than 5? In fact, it is. So we move 5 up 1, we move 3 down 1 and say 3, are you less than 4? Yes, 3 is less than 4. So we move 4 up 1 and move 3 down 1. 3, are you less than 2? No, 3 is not less than 2. So now 3 is already at this position, so we just drop it here. And now 1, 2, 3, 4, 5, and 6 are in the sorted part, so we move the divider over, and now we have 1 last element in the array to iterate over. And we say 7, are you less than 6? 7 is not less than 6. So what do? We just put it right back where it was. Good job, everybody. You just performed insertion sort.
Now that we know how insertion sort works, let's code it. Well, let's begin coding. And the first thing we're going to do is create a class called insertion sort. We are going to create a public void method called apply sort. We're just taking in the int array. The first thing we're going to do is set n equals to array.length so we can use this throughout the method. Okay, and now for the main logic, we know that initially when we start this, array index 0 or the first element in the array, it's always considered sorted. It's when we go to the next one and then go through the rest of the elements in the array that we perform all the steps through each iteration. Okay, so with that, we say for int I equals 1, I is less than n, the array length, I plus plus. Okay, so we're going to have 2 variables here. We're going to say int current element is equal to array of I. So this will be index of 1 when we start out. And then we say int previous element is equal to I minus 1. So initially, since I starts at 1, this is going to start at 0. All right, so now we have a while loop, okay, because we need to keep performing something on the current element when we check against all of the elements that are considered in the sorted part of the array. So anything that's less than its array index. So we're going to say while previous element is greater than or equal to 0, and array of previous element is greater than current element. So previous element greater than or equal to 0. This means that when we keep going back from wherever we're at in the array, we keep going backwards to check to see if the current element that we're holding, the current egg we're holding in our hand, if it keeps being less than the previous ones, well, eventually we're going to have a decrement operator on the previous element. And if it becomes -1, then we get out of the while loop. So we have array. Now we need to get the value from the array of previous element plus 1. We're going to set that to array of previous element. And then we're going to say previous element and decrement it. So what is this doing? So when we come out of the while loop, whenever we're done moving the egg or the integer down the array, and if it's no longer greater than the one previous, after that's said and done, we say array of previous element plus 1 is equal to current element. Basically, whenever the element that we're checking all of the ones in the sorted part against, whenever it's no longer can be moved down in the array, here we're just setting it and placing it back into the array. All right, and we've coded it. Now let's just go over one more iteration. Let's go over like 2 iterations of this whole for loop and go through the while loop just to make sure that you understand what's happening in the code. So we start out at the for loop int I equals 1 because we never actually start doing all the steps on the first element in the array because it's technically considered sorted when we think about doing an insertion sort. So the current element is equal to whatever is at array index of 1. The previous element is just the number 0, right? So I minus 1, 1 minus 1 is 0. So this is the array index of 0, not the value it's holding. And this while loop is saying, well, as long as that previous element variable is greater than or equal to 0 in the array at that position. So if we have 5, 2, and 4, like we did with the eggs, these are the first 3. The previous element 0 is greater than or equal to 0 because it is equal to 0. And the array at the previous element, so the array at index 0 is 5, is greater than the current element, which is 2. It is. Then we say the array at previous element plus 1, so this is where value 2 is now, equals the array of the previous element, okay, which is 5. So now 2 is going to be equal to 5. Decrement the previous element, which was 0, so now it's -1. Well, -1 is not greater than or equal to 0 when we come back through the while loop, so we get out of it. So now this is -1, so the array of the previous element plus 1, so this is -1 plus 1, which is 0, is equal to the current element, which up here we said was 2. Now this is 2, 5, 4 after one iteration. And we're going to do the same thing over and over again for each iteration until we get to the last element. And whenever we're done with that, then we're done. I'm going to put a couple of print statements in here. You can go ahead and copy it, and then we're going to run a test. I'm going to go ahead and put a method in here that prints the array. You can pause the video and copy it. And then I am going to put this in right here for the array. And so we're going to test this in the main method now. And this will help see you step by step as we go through the list what's happening. In the main method, we're going to go ahead and test this. I just created and instantiated an insertion sort class. We had the same integers for the array that we used with the eggs. We're going to print the original out, and then we're just going to execute the apply sort method. Let's see what this prints out. Here's the original array. The next iteration, we went to 2, and then 2 was less than 5, so they swapped. There's nothing else to do there, so we go into the next iteration, which is where 4 is, and 4 is less than 5, so they swap, but 4 is not less than 2, So it stayed in position 1 in the array. And then the next element was 6. Well, 6 was not less than 5, so it stayed where it was. And then it did the same thing for 1, 3, and 7 until we get to the final sorted array. Though this is how insertion sort works, I have other sorts coming after this. I want to go through about like 6 to 8 sorts. I did insertion sort first because the next sort, shell sort, uses insertion sort as part of the algorithm. So I want you to know how this works, and then we're going to get into that one. Have a wonderful day. Click these videos to learn something else, and I'll see you next time.